Okay, so just a quick introduction. My name is Brian. People call me Mr. Brian. I only teach like a few of you. So most of you are new here, but those of you are online, I think most of you are already my students. Just maybe some new students, right? So my name is Mr. Brian. I have been teaching for, I know I look young. I know I look very young. But I've been teaching for almost 10 years already. Yeah, so every week I teach about 800 students, but whether are you one of the 800 today, it doesn't matter. I just want to make this 2.5 hours. I know it's a long session, as productive as possible, as effective as possible. Because I know right now time is gold. Tomorrow's bio. I know you are nervous. But we just do whatever we can in this 2.5 hour session. Okay, so before we start, because 2.5 hours is not a very long time, there's only so much that I can do. So you can tell me what you want me to do. Like you can tell me what do you want me to prioritize. Okay, so that's one question to think about. So like, if you hate for the life of you light, you want me to do light, I can. Wave, I can. So usually it's wave and light lah. If you ask me, these two, people are usually weaker at. I'm going to do a couple of questions. There are some very good questions in here today. Okay, the questions are all from state papers. So it's high quality questions that can totally come out in your exams. Yeah, but I want you all to know also, it's not all so difficult lah, right? Because I handpicked these questions. Exam surely will have a balance, some easier questions, some harder questions. Huh? Okay. You tell me, right? You tell me, what chapter do you feel you are not very good at, that you want me to do? Chapter 3, chapter 6, chapter 2. Four, 5, 6. Okay. Chapter 5. Right. A little bit in every chapter. That's okay. I'm seeing a lot of chapter 3. Are you that bad with gravitation? Hello? Are you that bad with what's gravitation? No? That's okay? No, okay. You hate Newton. Okay, I think I kind of know what to do. All right. I'm going to start from the back. So I'm going to do 6, 5, and then 3. Okay, if I have time, I'll do 4. If I have time, I'll do 2. Okay, I did not include chapter 1. Chapter 1, chill out, right? But chapter 1, very easy. Okay, now another very important question that I know you all care about a lot is, I'm going to give you a 10 minutes break. Now you have another choice. Okay, you tell me if you want a 5-minute break, split out, or you want like a one-shot 10-minute in the middle. You want, okay, who wants 10-minute one-shot in the middle? Oh, no break, then hardcore. Who said no break? Who wants 5 minutes, 5 minutes? So you all prefer 5 minutes, 5 minutes, yeah? Okay. Right. Wow, this guy, I don't need a break. I don't want a break. Wow. Okay. We'll do 5 minutes, 5 minutes then. 2-hour break, John. Okay. You're hungry of physics. I like your enthusiasm. I've given you the formula sheet. By the way, guys, this is the SPM version. So this is the list that SPM gives. I know a lot of you are very afraid. Teacher, do I need to memorize this formula, that formula, this formula, that formula? In physics, usually what we test you is not the formulas, it's the concepts, right? So as long as you know how to apply, usually you are quite safe. Unlike at maths, we normally don't ask you to derive any formulas. So don't worry. And we'll start from the back. Huh? So chapter 6 first. Can you go to page 33? Page 33. We'll start with that straight away. Page 33. The page is at the top corner of the... Oh yeah, the notes is here. The top corner of the page, page 33. I've just done this in the normal class. Diagram 3.1 shows the mirror. This is a Penang question. Placed at a road junction. The purpose of mirror is to help drivers to see incoming vehicles from the main road. State the type of mirror. Concave or convex? Concave. Those of you in my class, I always say that this is a busybody mirror. I call this a busybody mirror, right? So you're obviously not from my class, and it's okay. We make mistakes. Okay, let me tell you what do I mean by busybody mirror. I always call this a kepo mirror, a busybody mirror. Don't need to memorize. Just look at how it is shaped. Yeah, just look at how it is shaped. It is so busybody that it can see things from here, from here, from here, from here, from here, from everywhere. You can see things from everywhere. And usually for this kind of busybody shape, convex, busybody shape, it is used for safety reasons. I call this the convex mirror, the busybody mirror. This mirror can see a lot of things going on, left side, right side, up and down, all can. Okay, so this is a busybody mirror. This is the number one question they like to test for mirror, which is this a busybody mirror or not? What is the professional way of saying busybody? You don't say, oh, the advantage of using this mirror is that it can be very busybody. Instead, we say, hello, it has a wide, take a set of notes here. A wide field of vision. Welcome. Okay, so we say convex mirror. Advantage for convex is always have a wide field of vision. Don't write it's busybody lah, right? Have a wide field of vision. I can see a lot of things. And why do I want to see a lot of things? A lot of the time is for safety reasons. Okay, for safety reasons. Huh? Can. As long as the words wide field of vision is there, can. Right. A kepo mirror. Now, I know this question is talking about the kepo mirror, the busybody mirror. On the other hand, we have the not kepo one. Not kepo usually for what kind of application? So we take a look at a cave shape. A cave shape look like a hole like it. You see light is going into this hole, this cave shape, concave mirror. I call this the not busybody one. And for very obvious reasons. Common sense. Don't memorize. Look at the shape. Do you think this mirror can see what is going on here? Cannot, because of the way it is shaped. So it's really common sense that I can only see a small part of things at a time, right? I call this a mirror that is able to help me to magnify things. Let's say if we take a look at the letter H, for example. Okay, let's say we are take a look at this letter H. This letter H is now going to display on this mirror as this big H. Usually it helps to magnify an image. And when do we want to do that is normally when, you know, your dentist like to use this, or cosmetic mirror. You know, when your dentist clean your teeth, they don't need to look at all your teeth at once. That's very distracting. They only have to look at one teeth at a time and slowly clean one by one. So, or those makeup mirror, cosmetic mirrors, those makeup mirror where when people apply makeup, they don't have to look at the entire face at once. They only have to look at a small part of their face and apply makeup, right? So to magnify things usually. Okay. Now the drawing part. Guys, this is a mirror. Please pay attention to how you draw your lens and your mirror. I would like to remind you, lens is a refraction. And our focus is always, let's say if I got a lens like this, a light go in and a light come out. Upper maksud refracts, light bends, and this is a piece of glass, lens is a glass. You ask yourself a common sense question. For glass, a piece of glass, light's supposed to pass through one. But for a mirror, yeah, reflect. So our focus is for lens is one in, one out, the light ray. For reflection, can I use the word one light ray go in, let's say, and let's say it is going to reflect like a mirror for mirror, and it's going to bounce off. So one go in and one bounce. So make sure when you draw lens or mirror, your head is in the correct mode. Are we drawing lens one or are we drawing mirror one? Okay. The easiest one is follow these rules for mirror. A straight ray through on C. You go and try to draw yourself. Straight ray through C. And then parallel. Yeah, can I just put C? Parallel to F, or F then become parallel. Okay. Oh, sorry. So for this one, you have an object there, straight ray through C, meaning you put your ruler to C, like this. I have a light ray go and touch the mirror, and it bounces off the same way. Teacher, do I have to draw a dotted line? This one, optional, not necessary, because our focus is this. One light ray go in, one light ray come out. Okay, number two, parallel. Can you draw up to this dotted line? You see this dotted line, dot. Parallel light ray. I'm drawing the second one. If it goes in parallel, afterwards, you need to draw to your F. Teacher, does it mean I'm going to draw to my F like that? It cannot. This is lens. What do I mean by go to F? I mean you put your ruler, go to F. For mirror, it still has to bounce off. So focus on one go in, one bounce. One go in, one bounce. But I do not get an image in this case. And what we need to do is to extend backwards. The light rays don't touch each other. What do? Extend to the back. Please extend with dotted lines. Yeah, everything other than the hit and bounce, go in and bounce, that one should all be dotted lines. Okay. The place where they touch each other is your image. Anything with dotted line is a virtual image. Guys, behind the mirror. Yeah, on the right side is at the back of the mirror. No, behind the mirror is virtual. Okay. And then state one characteristics of the image form. What can you say about this image? Upright is the easiest one. Upright becomes smaller. Do you notice? So you can say virtual. They ask for one only lah. You can say upright. You can also say, instead of smaller, we normally say become diminished. Virtual, standing up. The image is standing up. And also, guys, have a habit of labeling the word image. You draw a D, please write the word image there. Sometimes without the label, they will minus one. Okay. Virtual, upright, diminished. You write one that you are most confident. Virtual, upright, I think is one of the easiest. Diminished means become smaller. Okay, so we have gone through a bit of mirror. Now, the next page is also quite a good question, this one. Magnifying glass. What lens is this? Concave lens. Before you nod, you think first. Really? Concave?
Convex lens.
Your exam is in 2 days, right? Oh, this is scary. Convex lens. Aduh. This is a lens, not a mirror. Okay, this is a lens, not a mirror. By the way, okay lah. Quick one. So to those of you who are new, for every chapter I do this. If I only have 5 minutes to study, what must I know thing, right? In short, I call this an exam summary lah. So every subtopic, I'm gonna summarize the most important thing. Like if you only have 5 minutes, I'm not saying please study in 5 minutes. No, I'm not saying that. Hey, don't quote me. I'm saying if you only have 5 minutes, before exam, you flip. What are you gonna flip? I think I'm gonna flip this one to refresh my memory on all the very important concepts on like refraction, total internal reflection, lenses stuff, thin lens formula, optical instruments, and then mirror. Okay, now for your lens image characteristics, concave lens can never ever give you a magnified image. If you want to use a concave lens, it's always going to be diminished. It's always going to be virtual, upright, diminished, no matter what you do. And can I remind you that all your concave lens characteristics is the same as convex mirror. Lens and mirror, terbalik one. Okay, so you might be very, very good at mirror, or you might be very, very good at lens. Just remember to terbalik them, right? So normally, students are very good at lens because that's what they learn first. And then for mirror, you just terbalik. Yeah, convex lens, concave mirror. So that's why it's convex lens, because convex is the only one that can give me magnified image, can possibly give me magnified image. Yeah. Okay. State one characteristics formed by the image. Can you give the easiest one? You use magnifying glass, become magnified. Free mark at this one. Yeah. State one only. Okay, you can also say that it's virtual, if you know. You can also say that it's upright. You think of it, when you use a magnifying glass, does the image you see ever get inverted? No, it's always standing up. It's always upright. Yeah, so upright is an easy answer. Magnified also. If virtual, you don't know, never mind. Because they asked for one only. But see, you got two diagrams. Can you look through the two diagrams? They got different object distance. And then you get a very different image. Okay, compare the object distance, image distance, that one. I'm not going to do a lot of comparison question. This is probably going to be one of it. Object distance, I hope you know, is measured from the object to the lens. We call it the letter U. Image distance, we call it the letter V. Okay, so if you're not sure how to see your U and V, like this, U and V, and then the size of image, one is definitely bigger than the other. This guy is definitely big. Okay. So in all of the answer, 5.3 is bigger than 5.2. 5.3, the U is bigger, V is bigger, image is bigger. Okay, I'm gonna answer. I don't know how you all answer your comparison question in school, but whatever any marking scheme says, I feel you should always write what you want to compare. Okay, object distance, I'm comparing the object distance in which diagram is bigger or smaller. Yeah, so I'm going to say 5.3 is, you want to use the word greater, larger, bigger, longer. It's okay. Okay, some of your teachers says, go ahead and write the symbol greater than if you want. Okay, if your teacher allows that, SPM allows it. If your teacher say, I don't like this, don't write this, then follow your teacher. Your teacher is the one marking. Okay. but SPM allows the inequality symbol actually. Image distance in diagram 5.3 is again greater. Greater, larger, longer, higher. Maybe not higher, higher is a bit weird. Okay, all greater then. And so it looks like the relationship is going to be the greater in this question. For a comparison question, you follow the picture because the picture is saying, oh, if I put my object further, then it will be bigger or the image distance will be greater. Just follow. You can write greater, increase also can. The greater the object distance, the greater the image distance. As the object distance increases, the image distance increases. Can. Or if you're a very negative person, you can say smaller, right? And decrease. Up to you. Same meaning. Okay, can you go and do part E when you're done? I would like to see how you answer part E. If you need any formula, it's in the first page. Okay, if you need any formula, it's in the first page. This one also greater. Okay. Make sure you know how to answer this kind of relationship question and comparison question. It's supposed to help you to get marks. Relationship and compare. Okay, it's a format that will definitely be in the paper. It's supposed to help you to get marks. Focal length of K. If you need any formulas in the front, That's a good start. Oh no, math error. You're gonna leave it like that? Can you leave it in a decimal form? Oh, you haven't flipped it. Okay. Yeah, decimal is better.
How many decimal points are there?
3 decimals, isn't it?
Okay.
What do you get?
1.04.
Oh, that's incorrect. I don't think any one of you got it.
So is it 0.955?
That is wrong. That is wrong. Okay, did anyone get 2.03 something? 2.03 something. None of you, all wrong lah like that. Right, all wrong lah. Right, so this is the part that differentiates whether you are A plus or AD, right? Not so sometimes, okay lah, I know lah, it's just 2 marks. We still got 98 marks, right? But sometimes the 2 marks makes a lot of difference lah. Object distance is 1.3 cm, while image distance is 3.6. Okay, you all have a strong start. You all tell me, teacher, this formula lah, this one. That's good. And then the rest is rubbish. Can I just say the rest is rubbish? U is 1.3 cm. Okay, and then you write V is 3.6 cm. What is the problem here? No, cm is fine. Cm is fine. You're overthinking this. The plus minus sign. When I taught all my students this, I say the number one mistake is the plus minus sign. This formula is damn easy. You see, the first thing you all did was, oh, teacher, this formula can, this formula can. And I said, yes, yes, yes. Then I wanted to see what you saw, right? So all of you got the formulas, right? It's a very easy formula. It's given. Anyone can do it. Now, the problem is, do you know how to take care of your plus minus sign with the F, the U, the V? U is always positive. Because U is always at the correct place. The plus and minus sign is to see whether is it logical or not. So U is always at the correct place, so always positive. But the V, if you look at diagram 5.3, is this a virtual or a real image? A virtual image is a negative distance already. How do I know virtual? Because number one, got a few things to look at. Number one, the dotted lines tell me it's virtual. Number two, because some of you get confused. Teacher, is it left side virtual or right side virtual? Now I ask you, for a lens, a glass, you know, if light go into this glass, where do you think it should go? Do you think it should go to the right side or left side? Glass, this is a piece of glass. Right side. That's the logical thing that should happen. Anything that is logical, supposed to go over, is a glass. A transparent piece of glass, that is real. Left side is virtual. Oh, teacher, I'm going to memorize right side always real. Please don't. My students also know I always highlight to you, mirror is the balik. I give you a mirror, let's say. You tell me, if light go into this mirror, do you think it will go to the left side or right side? Mirror, left side. Is going to touch the mirror and bounce off. Left side is real. So you ask yourself, for a lens, where should it go? That side will be real. For a mirror, where should it go? That side will be real. Right now, the right side for mirror is virtual. So it's not so much of memorizing. I want you to just use common sense. For glass, where will it go? Or right side, it will go to the right side. Go in and go to the right side. Right side real. For mirror, where does it go? It hit the mirror and then bounce off. Left side is real. Okay, and so a virtual image is negative. Your V needs to be a negative value. Okay, that is all that makes a difference. A tiny negative sign. cm or meter, both okay. I'm just going to do cm, guys. Positive 1.3. V is negative 3.6. The rest is the substitution easy, formula easy. Right, my students know this. I from the start already said there's only one mistake always, the plus minus sign. Please be very, very careful. Okay, and this is what I got. I'm not really interested in this number. Okay, or I'm just going to flip it. Either you flip it around or you see how actually it's just 1 over the answer. If you can just do 1 over your answer button, you will get answer. Answer is a positive 2.035 cm. If it's plus, it's okay for you to leave the plus. Okay, you don't need to write. But if it's a minus, let's say if you get minus, please leave the minus there. But this answer is a positive. Okay, the marks is given here for this question. and also here. Everything else, if you never write, it's okay, but I highly recommend you to always write the formula you're using, so that your examiner know what you're doing. 2.035. Okay. Right. I think for the next question, page 37, can I just do the part C? So don't worry, the answers all I'm gonna send later. Can we do part C? Okay. You have an astronomical telescope, and then they say your telescope contains an objective lens and eyepiece. You have three types of lens used as the objective lens of telescope. Okay. Can you go and pick which lens would you most likely choose? PQ or R? Okay. What's your pick? PQR. The answers are. The answers are. Okay. I'm gonna start off with the easy one. Guys, we are focusing on the objective lens. Okay, objective lens. Objective lens. I'm gonna start with the diameter first. We want a big diameter. Okay, you can just write big lah. Normally is okay already, but normally I'll just add big diameter like this. Okay, a big diameter to produce what kind of image? A bigger lens, will it give me a magnified image? Nope. Thank you very much. Brighter is the word. Okay, those of you in my class, you know, I always say brighter. The size, the objective lens size allows how much light can enter the lens. The more light can enter the lens, the brighter it will be. The word is brighter. Bigger is wrong. Sharper is wrong. Not accepted. Sharper is not accepted. Bigger is not accepted. Brighter. You can also say to produce a brighter image, because what? More light can enter. Okay, I'm not saying about the thickness. I'm just saying about the thickness same, power all same, just bigger in size. Yeah, just bigger diameter. Okay, focal length, how to see? There is a formula for I do not know what time. What time will I roughly start other chapters? I'm not sure. I'll see the flow. Okay, focal length. You have to use this formula, no? FO over FE, kan? Guys, in this week's lesson, and those of you who attended my class, this week's lesson, I just talked about this formula. There was one essay question that we did, remember? FO over FE. If you want to look at the objective lens focal length, it needs to be high so that the magnification of telescope will be high. Now, do I write 100 cm? Mampus, if you write this. Straight away wrong. Guys, you are supposed to just give the best modification. So you don't tell them what to do. You just say, oh, I want it to be as long as possible. Longer focal length, larger focal length, can.
Bigger can.
Bigger can? This one is so that you get a higher magnification. Or you want to keep it simple, a high magnification means what? To produce a bigger image. Now you can use the word bigger. Not brighter, bigger. Okay, so the answer for part D is that we are choosing R, lens R. Okay, and then there is the refraction topic. Okay, let's go through refraction also. Page 39, the next one, Terengganu. To focus more object at a further distance. No, I don't think I'll accept that. I want a more accurate answer, and the most accurate answer comes from the formula. I'm deciding it from the formula. Objective lens focal length. Large, high magnification, bigger image. That's all we accept. Okay, so don't overthink it. Huh? Sometimes we know this formula. And I told you this formula is important. Important for telescope. This one. Okay, and it's not given in the formula sheet, this one. Okay, number 2. Sorry, next question, Terengganu, page 39. You have a student observing a pencil. The pencil appears to bend due to the phenomenon of refraction. Okay. Apa maksud refraction of light? Oh, can I repeat what is O and E? Sure. O means, wait, someone asked this. O means objective lens. E means eyepiece. Objective lens and eyepiece are O and E. Okay, refraction of light is what? Got 3 key points. Any key point, any key point. You tell me anything you feel like it should be in the sentence. Don't have to be in order. Huh? Medium. Medium is a word. Different mediums. Mediums of different optical densities. When it's refraction, there is one physical quantity that will always change. What is that?
Speed.
Speed. Thank you very much. Speed. You must mention speed or velocity. Can I just write V here? Okay. And one more, maybe you can add maybe the word bending of light. Okay, or change in direction. Bending or change direction. In SPM, these 3 things must be in for you to get full marks for this 1 mark definition, right? So refraction of light is, okay, I can say the bending of light when propagating through mediums of different optical densities. Okay, but why does it bend? Why does it bend when it go through different mediums? Because the speed change due to the velocity or speed change. Must mention this, must mention your different mediums. Some teachers are very particular about the word optical. They don't want you to just write density. They want you to write optical density. And also one more key point is the bending of light. You don't want to say bending is fine. You can say change direction. Bend and direction change is the same meaning. Okay. Now the student is seeing the pencil. Let's say the student is here. My question to you, is light traveling from the pencil to the student or student to the pencil? Student to pencil. How is the light moving? In which? Okay, I know why a lot of you are thinking student to pencil, because you're thinking you are seeing the pencil, but the light is going into your eyes, what? The light is going into your eyes, right? So, oh, that's very scary. Okay, yeah, it's going into his eyes lah. So the light is going from Why is this important? Because in the part B, you need to explain how does the bending occur. And I'm going to say that, oh, the light is traveling from a dense medium to a less dense medium. From water, go to air. Right? If you terbalik, then wrong already lah. Right? So why does the phenomenon occur in part B? They ask for 2 marks. You can say, oh, because light is traveling from denser to less dense medium. As long as there's a different medium, light ray travels from denser to less dense medium. Okay, sorry, can I add a word? From optically denser medium to less dense medium. And so it will the light slow down or speed up? Denser to less dense.
Speed up.
In the denser medium, it is going to be faster. When it's very dense, it slows down the light a lot. Yeah, slower. So the speed increases. The light will travel faster in air than in water, let's say. Okay, so there's 2 points already, 2 marks, but I can write other things. Do you think it will bend away or towards the normal?
Away.
Okay. Away.
Okay, away, away, you are very sure. Okay, let's look at the, okay, away, very good, away. For those who still have a hard time with this, I always tell my students FAST lah. If it's faster, it will go away. If it's slower, it will go towards. Faster away, slower towards. Okay, in this case, it's the faster one. So the light ray will refract away from the normal. Okay, they also accept one more extra point, and that is the incident angle is smaller. Because you refract away, of course, the refracted angle will be bigger. It's smaller than the refracted angle. Okay. So got a lot of things to write for 2 marks. So any 2 points? Yeah, any 2 points? Anything about refraction? Now, can you draw part C? Complete the ray diagram below. Okay, this one is a K-BUT question because now, you read carefully. The diagram shows the position of an image observed by the fish. The fish is now the observer. Okay, the fish is now the observer. Before you do, you think, is the light going from the image, who to who? The beetle to the fish or fish to the beetle? Beetle to the fish, read the question carefully. Observed by the fish.
Oh yeah.
Observed by the fish. It's K-BUT. Yeah, I know. A bit K-BUT this one, because the observer is always at the top. But then now they put the observer down there. Then how? Okay, I don't know if you know this, but got 2 light ray that we're looking for. The first mark you will get is when you draw from the fish eyes to the image of the beetle with a straight line. Okay, so make sure you pass through the middle here. So down here is a solid line, but up here is a dotted line. This line like this, 1 mark. Down there is solid, up there is dotted. Okay, I'll explain later why is it dotted. And then for the real beetle, you just connect it to this point with a solid line. Okay, I use a different color so you can see. The green color one, 1 mark. The red color one, 1 mark. Maybe we can add a bit of arrows. The beetle is going into the eyes of the fish. And it is bending towards the normal, if you notice. You see, it is bending towards the normal because it slows down in the water. Right? So it should all make sense. Then teacher, how come the dotted line is a straight line to the image? Because that is what the fish will see. This one is what the fish will see. Our eyes can only see light as a straight path. Our eyes will always trick us up. Our eyes will only see light as a straight path. I call this image as a apparent image. So if you are the fish, you're looking at the top, and then you think, oh, the beetle is there, but that is called the apparent image, or I call it the fake image. Apparently, it is there, but actually, it is a bit lower down there. Okay, it's the apparent image, and this is called the real image. Dotted line don't need arrow. The arrow only is on the actual light path. Okay, the arrows are only on the actual light path. So light actually go in, and then because it goes to water very dense, it will bend towards the normal. It will go to the normal. That's why bend down like that. Okay, the 2 light ray for 2 marks. This one a bit kebat, huh? Okay, then essay question. This Pahang one, you got a curved mirror used as a security mirror to watch out for shoplifters. Can you pick out the best mirror? You want to watch out for shoplifters. You got STUV. Huh? You want to use as security mirror? Give reasons for your choice. Okay. It's not a difficult question. If you are asked this question, go and do it. You are very likely going to get 4 marks. Okay. Right. Okay. The answer is you. Why are you laughing? Okay. The answer is you. All of them got you. Okay. Why do we want a convex mirror? Yeah, this has to be the kaypoh one. This has to be for anything safe, for safety reason, for security reason. It has to curve outwards like this so that it can see a lot of things going on at once. Guys, I got no time to draw table for you in exam. Please draw table, answer in table form. Okay, essay must answer in table form. So you write convex mirror as the curved mirror. Okay, why do we want convex mirror? I say because it is kaypoh, but in a professional way, please. Wide field of vision. What about the size of the mirror? Use the word field of vision, and that's the most accurate term. Why want it to be big? Is bigger always better? Is bigger always better? A big size of mirror, why? Why big? So that more light can enter the mirror, and so you get a bigger reflection of everything. Okay, I don't think I would say bigger image though. I would say maybe you get a bigger viewing area, right? A bigger mirror. To reflect more light or brighter image, you can say that. Okay. Or you can say to get a bigger viewing area. Okay, like for the same angle, I'm not going to say the field of vision is going to be wider. For the same angle of vision, now I just get a bigger viewing area. So the angle is the same, but I get to view it bigger. Okay, position of curved mirror. Why do we place the mirror at the top and not on the floor? Why on the top, not on the floor? Would you want to put a mirror on the floor? Why would you say no? Common sense, just common sense. Why would you say no? You put on the floor, how to see? You put on the floor, the shop has a lot of things. How are you going to see? Okay, just that's why we always put at the top, because you look at the top. Is there anything blocking the light if I were to put a mirror here? Nothing. But if I put on the floor, all I see is your feet. I don't want to see that, right? So high position of curved mirror, just to avoid obstacles.
There is no obstacle blocking.
Can? So in your own words, yeah, to avoid obstacles blocking the light, let's say, or blocking the mirror also can. Yeah. So it's more for like you don't want it to be blocked. Okay. Prevent light from being blocked by other objects. Can? Okay. Last one is free mark. Why would we want a weak reflector, right? So strong reflector. This one you can say to produce a sharper image. Okay. This is optional due to better reflections or stronger reflections. Okay, so U is the answer. And then the next page, that one last question for endoscope. Okay, I would like you to look through the question, this essay question, and you tell me what phenomenon is this? Yeah, what light phenomenon is this?
Total linear reflection.
Yeah, thank you very much. How many of you are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's 11 of you versus 160 of them. Okay. Total internal reflection. Yeah, it's total internal reflection. The moment I see a fiber optic, I already know it's total internal reflection. Chapter 6.2, they ask you to write based on characteristics of material of the inner core, purity of the material, flexibility of material, and then type of protective jacket. Okay, so that is how many points are 1, 2, 3, 4 only. Okay, but you don't just write 4, you need minimum 5 to get 10 marks. Let's start with material of inner core. Denser or less dense? Denser. Okay, now you remember. That's what matters. Yeah, so you answer just answer freely. You make mistakes right now, it's okay. One. I love when students make mistake in class. It helps you to remember better. Okay. Again, do in table form. Wait. Yeah, I know I got no time to draw table now. You can say a denser or high optical density material or inner core. Okay. Reason, you can say, what reason you want to say? Okay, you can either say a high optical density so that total internal reflection can occur. Okay, I'll explain why is this in a bit. Or if you just want to say high optical density is going to give me a high refractive index, also can. Okay. Number two, they also accept if you write high, by the way, high refractive index is the N value. Can I just keep it short for this one? A high N value again. Same thing, so total internal reflection can occur. So you can write this as two separate points. And a question I get asked a lot, teacher, can I write the same reason or not? Can. You can write the same reason. If that you feel is the best reason, but it repeats, right lah. I have seen some extreme cases where all the reasons are the same in the mark scheme. All correct. Okay, so reasons can be repeated, but some teachers will say, maybe you try to rephrase it, change the English a bit lah, so that they don't look so similar or what. But actually in SPM, all okay one. Yeah. Okay, number three. Characteristics and material of the inner core. Can you tell me about the critical angle of inner core? So what critical angle? Big or small? Okay. Which one makes it easier for total internal reflection to occur? A high N meaning a high refractive index. Yeah? In exam, you're right nicely. Huh? Not everything big isn't always better. Small in this case. Smaller critical angle. I'll tell you why in a bit. So I will explain one shot. Smaller critical angle, easier for total internal reflection to occur. Okay, before we continue with the rest of the answers, let's think about total internal reflection. Okay, we start with the basics. There's only two things that you need to know for total internal reflection. Number one, light has to travel from a denser to less dense medium. If you check this box, then maybe total internal reflection can occur. The second box you need to check is that the incident angle must be bigger than the critical angle. In short, I must be bigger than C. Okay, I must be bigger than C. So always remember, guys, why do we use the word total and then internal? Because it must always get stuck inside. That's why we use the word internal. Inside what? Inside a dense medium. So for example, if I got a glass block like this, total internal reflection is like this. The interesting part is, I got light go in this glass. Glass is transparent now. Right? Glass is transparent. I think light will come out like that. Right? I think light will just come out. But something magical happens. This glass will suddenly act like a mirror and it gets reflected like this. The word internal means this. It is stuck inside a dense medium. It doesn't come out to air. It is stuck inside total internal. That's why the inside part must always be very dense. Right? The inside part must always be very dense for total internal reflection to occur. The core is always the densest one. The inside part is always the densest. And then the outer cladding is less dense. Yeah. Okay. So like this. And then another thing is the critical angle. Why smaller better? Let's say my core has a critical angle of 80 degrees. Now my question to you, do you think incident angle, which is, I label at the top, okay, let me zoom in. Do you think this incident angle can easily achieve more than 80 degrees? Very hard. My light ray has to travel at a very specific angle that is more than 80, then only total internal reflection can occur. Now let's change it a bit. What if my critical angle is just 20? A lot of the incident angle, light coming in from all different angles, are going to get reflected as well. Because incident angle very easily achieve this second condition. I always bigger than that 20 degree. I always very easily bigger than the C. Okay, so if you make the criteria even lower, it's even easier. The critical angle even smaller is even easier for light to get reflected like this. Okay, and then number 4, material of inner core, purity of the material. Let's talk about that. You can say high, purity. Okay, best reason to say is reduce signal loss. Okay, to reduce signal loss. What does that mean? You know, in the core, guys, I don't know you all know or not, fiber optic is normally transparent. You know when you eat bihun or glass noodle, very thin, right? That's how the fiber optic looks like glass noodle like that. So very thin strands, glass noodle, they're transparent, but for some reason, light will get stuck inside. Light will get stuck inside in the very dense core. And so the light path looks something like that. It gets reflected and it is stuck inside like that. And you want it to do that so that it can travel information from, it can move information from one side to another end of the fiber, right? So as you put it down this person's esophagus, you can see whatever's going on in the digestive system, and then it displays in the screen, right? So light actually travels through that core like that. But what if at one point, suddenly it's not very pure? Let's not forget, this is a piece of glass. Not all the time you get total internal reflection. Sometimes, if you don't fulfill these two conditions, what happens? It will just come out. If you don't fulfill this condition or this condition, it will just come out. At some point, it's not very pure. The critical angle may be too big. The signal will just get lost and it will just come out like that. This is what we call as the signal loss. So instead of the light gets stuck inside, it doesn't get stuck inside. At some point, it's not very pure. It will just come out. That is what we mean by signal loss. The light is gone and it's missing. You will lose some information then. And number 5, what else? Flexibility. You can say high. Of course, you want flexible. Guys, your digestive system, is it a straight line or not? If yours is straight, I don't know, what are you? It's not a straight line. And so when you put that in, make sure the thing is flexible so that you can bend around the corners. High flexibility of material. High flexibility, you can just say can bend easily around corners. Okay, or around any narrow path or so on. Okay, and then type of protective jacket. Okay, so for an endoscope, it's a bit special. It's not just the glass noodle thing. They will also put a protective jacket because the glass is, what if the glass breaks? Right? And it's in your throat. What if the glass breaks? Okay, no, I think you just swallow it and then you just you will discrete it up. But we don't want any of that to happen, right? So normally we put a protective jacket around it, and usually we use something a bit soft, rubber. Rubber is quite a good one. No, I think rubber is the best. Yeah, I think rubber is the best. Rubber protective jacket. You say it is soft to protect internal organs, let's say. plastic. I'll just say to protect the internal organs. Yeah. If really that is the best choice. Okay. Break time. 5 minutes. Okay. It is 1:25 right now. We'll come back at 1:30. Are you going to walk around the house? You play your phone, you want to sleep, do whatever you want, you want to go toilet, go. Okay. I have some snacks for you. Hold on. Pause recording. I'm sorry, online students. I got no snacks for you. You can. Break time always pass by very fast. You can eat while we continue. Okay. Page 24, please. Chapter 5. Very cool. Okay, page 24, chapter 5. I'll go through some questions. Some questions I think I don't have time to do, but there are some very good ones, and I feel there's a high chance that essay is going to come out with. Okay, there's a high chance that essay is going to come out with because it's a big topic. Okay, question 24. Page 24. There are 7 types of electromagnetic waves to form a continuous spectrum known as the electromagnetic spectrum. Underline the correct answer. Electromagnetic waves are made out of electric field, magnetic field that oscillate what? Perpendicularly or parallel? Just to refresh your memory, if electric field moves front and back, your magnetic field will always oscillate up and down. So one up, down, one front, back. Therefore, they're always 90 degrees to one another. Okay. Based on the diagram, state the electromagnetic waves that have the highest frequency. Okay, they stated all the wavelengths for you, but which one has the highest frequency? Gamma ray. Okay, for those of you who don't know how to see this diagram, the one that is the lowest lambda is going to give you the highest frequency because of the formula V equals to F lambda, right? V over F equals to lambda. I always rearrange like this because lambda is always the responding variable. When F is high, lambda is small. F is at the bottom, lambda is at the top of the fraction. One at the bottom, one at the top means inversely proportional. Okay, gamma ray. Okay, which wave is used for drying paint on cars? What do you say? Heat wave?
Heat ray.
Heat ray. Heat ray. Can you pick something from this list? You are actually close. You're actually close.
Oh, that's
one of it is actually heat. Which one is it in this table, in this diagram? In which one is hot one? Okay, for those of you who say microwave, is because you cook with a microwave oven, right? For example, that produces heat. But no, it's infrared. Infrared is heat actually. Yeah. Ultraviolet is another thing. Ultraviolet is the one that can kill your skin cells, right? You get sunburn and all that. Infrared ray, or just infrared will do. State 1 characteristics of an electromagnetic wave. What kind of waves are electromagnetic waves? Okay, transverse or longitudinal? Let's start with that. Transverse or longitudinal? Do you trust this answer? Do you guys trust this answer? Transverse wave. So you can just say that it is a transverse wave. They are transverse wave. Okay. I hope you know that it is not longitudinal. Because there's only one example for longitudinal you must know. Very good. It is not longitudinal because longitudinal is only sound. For your syllabus, it's only sound wave. So sound wave, longitudinal, everything else, transverse. Okay, and got many other things to say. If you know the speed, you can also say it moves at 3 × 10⁸ meter per second. Does it need a medium or not? Electromagnetic waves. Does not need a medium. To propagate. Okay, I think these are some of the good answers. How do you all memorize the list? I'm interested to know, those of you who I don't teach, how do you memorize like radio micro?
I cannot use that. Okay, you know art, right? Radio, right? Ron, may I visit your ex-girlfriend?
That works. Ron, may I visit your ex-girlfriend? That works. Or
That Ron. Your money? Very.
okay, and you need to know what you're remembering for. I always say this, the one with R, I do this a lot in class already. Real money is very useful and extremely good. Real money is very useful and extremely good. Sometimes the picture would write from left to right, sometimes right to left. It doesn't matter, but R always means, or radio always means the one that is the longest wavelength. Okay, longest wavelength. For what about your rainbow colors, guys? Visible light is what? Rainbow colors from red. How do you remember your rainbow color? Red. Are you sure it's blue first before green or green first before blue?
Yeah.
Roy gave birth in Vietnam. Red, orange, yellow, green, blue, indigo, violet. That's the answer. Okay. Why is this important? Again, because red color, just like the letter R here, the letter R here is also the longest wavelength. Okay. Red, orange, yellow, green, blue, indigo, violet. Roy gave birth in Vietnam. Okay, let's move on to, I'm going to skip the Terengganu one. Let's move on to page 27. Page 27. I only took out the section, the part C. For the waves PQR that can be used to measure the depth of the sea, which one will you pick? Indigo violet, yes. Okay, a lot are selecting R. But people select Q also. Okay, you need to know to measure the depth of the sea. We always use ultrasound, not microwave. Okay, we use ultrasound, not microwave. Wavelength, long or short? The answer comes in whether do you want it to diffract or not. So if your diffraction knowledge is very good, you'll be able to answer this. Do you want it to diffract or not? That will tell you whether the answer is long or short. Okay, is long always better? In this case, it's short. Okay, type of wave is, you write ultrasonic wave. Okay, ultrasonic wave. What's so good about ultrasonic wave? Why do we always use it? Okay, very good. High frequency. It's high frequency, just 2 words. Get marked already. High frequency means high what else? High energy. Got one more. High what? High penetrating power. Okay. Yeah. So these are the three things that I already is in my notes here. You all, those of you who are my students, this is just a quick revision. I always say high frequency, high energy, high penetrating power. It can go very deep into the seabed, which is very, very deep. And it can pass through a thick volume of water, doesn't matter. It can go down all the way, reflect, and come up all the way again. Wavelength, I want it short. Short wavelength. Yes, lambda is wavelength. Aduh. Okay, short wavelength does not diffract easily. Easy to reflect also can. Guys, the purpose of measuring your seabed is for you want the wave to go down all the way and then reflect up again. I don't want it to spread. The word diffract means spread. So when I send down the wave, right, I don't want it to go sideways and spread out, because the more it spreads, the weaker it will be. Okay, so diffraction means spreading. Longer wavelength, easier to spread one. Shorter wavelength, difficult to spread. Okay, and easy to reflect, that means it will be very strong. You tell me, short wavelength, is it high or low frequency? High frequency. High frequency always means high energy. If the wave is weak, how is it going to go all the way down and then still have energy to go all the way up? It needs to be strong to do that. And then number three, which wave is best skewed? It's a bit warm now. It off randomly. Okay, I can. Let's take a look at question number, this one. This is a language question. I want to do this whole question. Okay, I'll see whether I want to do the whole thing because I want to do the next one also. Okay, this is the bad thing. I want to do too much with you, then I don't have time for the rest. Okay, we do this first. Page 28. Okay, quick one. Based on diagram 9, state the wave phenomenon that occurs. Reflection, you see the wave go down and come up? Reflection can? You want to add reflection of wave can? Yeah, or just reflection also okay. Okay, explain how the ship was able to determine the depth of the seabed. How to determine depth of seabed? Let me do part B. How? Let me do it here. Actually, it's very easy. This kind of reflection to determine depth. You just say, this guy sends the wave. At this part, wave get reflected. At this part, I receive the wave. Send, reflect, receive. 3 marks, 3 points. And I'm going to add one more thing to calculate the distance. I'm going to use a certain formula, right? A formula that we have used a lot in class also. So, okay, because they put in the picture, some of you say, teacher, I don't know what's a transducer. Never mind, I just follow the picture. The transducer sends or emits also can the ultrasonic wave. Ultrasonic is a type of sound wave to the seabed. Ultrasonic waves are reflected on the seabed. The reflected ultrasonic wave is received or detected also can by the receiver. Last one, the depth of seabed is determined with the formula. Okay, you want to try or not? What's the formula? This is actually just distance formula. Okay, speed is equals to distance over time. Distance is what times what? Distance is what? The formula. Speed times time, huh? Speed times time. But the time you must always divide by 2. Okay, because let's say if you start the timer right here, you start the timer, okay, when you send down the wave, the time is always the total time for it to go and come up. Right? I always say this in class. For reflection, time is always total time to go down and come up. So you must take the time and divide by 2 to find out the depth, right? So use this formula. Maybe you can explain a bit where V is the speed of ultrasound. Okay. And then T is the, T is the total time between the wave emitted and the wave received. I know it looks very long, but let's just focus on some key points up. I just need to send down the wave. I have the wave get reflected and then at last received. There's 3 points. I want to talk about the formula, and the rest is just explaining about this formula a bit. Okay, so when you study things, you don't blindly memorize every single thing. Too much for your brain. Just take some key points. Send down wave, reflect wave, receive wave. You form your sentences yourself. Yeah, should be fine. Okay, can you do the calculation in part C? I think this one quite easy. This formula is important. This D equals to VT over 2. You cannot find this formula in the formula sheet because it's just distance formula, just speed times time. Yeah. Answer 0.03 meter if you got it. 0.03 meter. $37. Wait,
It wasn't any longer.
guys, did you put the times 10 power negative 3 for time? Where did that come from? The time. 2500 ms is what? Is it meter second? Millisecond. How can time be meter? Right not? Milli. And milli means what? Times 10 to the... So you either put a 2.5 seconds, milli, you change to seconds. Guys, you have to use SI unit or else your units are not going to work. Or else you're not going to get meter. You don't know what to put here. Okay, so if that part wrong, then affect already the rest. By the way, you change unit. Be careful of your unit. You change unit, you already get 1 mark. It means you write the 10 power negative 3 or 2.5 already is 1 mark. You sub everything nicely in the formula, another mark. Then the final answer 1 mark. So small things like this, you miss out the milli, putting wrong here, you lose 3 marks straight away. Okay, milli has a value of times 10 power negative 3. Part D. For part D, I don't want to go through this question. Later, I'll send the answer because I've done it in class before, the exact same question. You go through the 4 retaining walls, but a quick one, which one will you pick most likely? PQRS, which one? Part D, retaining wall. Okay, answer is, Kenan, have you figured this out? Do you need help? Badira? Okay, welcome. But the answer is which one? PQRS? P, the answer is P, correct? Okay, why do we want to build at the bay? Very good. So for those of you who don't know what is bay or cape, bay is the part that is pointing in, and cape is the part that is pointing out. Cape, bay, this is the water. This is the seawater, by the way. So the wall that we are trying to build is usually a retaining wall to protect the bay, because normally at the bay, there is a lot of activities going on. Okay, so we can do a lot of water activities at the bay, because for those of you who remember your refraction very well, you know that water waves would always focus at the cape like this and diverge away from the bay. Right? You presented this. Okay. Good to know. Okay, bay, you can just say things like, oh, because the water at the bay is calmer water, or you can say low energy. Okay, or the energy diverges at the bay. That's why you build the wall at the bay, not at the cape. And then sloping retaining wall, this one, you can say to reduce the speed, right? Because as the depths, remember this is a refraction concept. The smaller the depths, the smaller the speed of the wave. So the wave is forced to slow down as it approaches the wall that is sloping as such. The smaller the depth, D means depth, the slower the wave is going to be. Uneven surface. Why don't we put a perfectly smooth surface? Why one uneven? So that we get an uneven reflection. Guys, if I got a flat wall like this, you will have a very nice reflection all the time. So wave go in, reflect nicely. Wave go in, reflect nicely. I don't want, I want to put uneven so that wave go in, go in, go in, it reflects all over the place. And so the wave energy gets cancelled out also. Overall, I want a very weak reflection. So uneven surface is for that reason. Waves reflected in different directions. Okay, you can add on and say it reduces the energy of the wave. If you're going to build a wall, I will say this, right? If you're going to build a wall that is low, you might as well don't build it. Yeah, you might as well don't do it. If you're already going to build a wall at the sea, you're going to spend so much, make it high lah, right? So that the water won't overflow. So you can just say, so you can say to block off the waves, you can say to avoid water from overflowing. Okay, or to block. You can also say to block high waves. Same, yeah. Same. Okay, it's the same one in the book. So the same one that we did in class. Okay, next page. I drew for you. There I wrote seawater and then bay and then cape. Cape is the part point out. Bay is the part go in. In BM, bay is called Teluk. Cape is called Tanjung. The one that you learned in geography. Okay. Next one, this one. You got electromagnetic wave signal transmitted by communication satellite. Keyword communication satellite. What wave do you think they are using? State the electromagnetic wave spectrum. Is it radio or micro? Microwave. Okay. Those who have my notes, you know that I put a star for this one, communication satellite for microwave. Okay, why microwave and not radio? Another question is, do you know which wave is stronger, micro or radio? Is radio wave or microwave stronger? More energy? Microwave, it has more energy because it has a higher frequency. Microwave is stronger for anything that you need to travel a very far distance. For example, to the satellite, this is the Earth. Let's say this is the Earth. You need it to travel very, very far, to outer space, go to the satellite there. You need an extremely strong wave. Radio cannot do it. Yeah, radio cannot cut it. It has to be micro. Microwave is stronger. It's always between these two. People mix up these two because these two both for communication. Okay. Less refraction. Cover less distance. Don't know what you're saying. Less energy, lower frequency. You mean radio wave? Radio wave has lower frequency, lower energy, cannot travel too far, low penetrating power, cannot pass through the thick layer of atmospheric layer to reach the satellite. Let's talk about this one. Your parabolic disc. Okay. You quickly go through, you see which one you want to pick. Which one will you pick? I want to warn you, the moment you pick the wrong one, usually you will maximum get 6 marks only out of 10. Okay, normally if you pick the wrong one. Okay, most people are saying K. K, the answer is K. This is a very easy question. High frequency, one easy way to say it, you can say high energy. Why same as focal length? Because same, sorry, wave signal will converge. Yeah, converge means focus at the focal point. Okay, so meaning you want to put your, this is your disc, this is a circular bowl shape. And at the focal point here, you want to place the receiver because all the waves that go in will all focus to that point. So you get a very strong reflection at that point. Okay, that's why you place your receiver at the focal point, and that distance is known as the focal length. Small letter f is focal length. Big letter f is focal point. Yeah. Okay. In this case, big is better. Big diameter to receive more signal, right? If you got a big disc, you can receive more signal. Receive more signal. Okay. Height. Why high? Less obstacle. So it's the same reason like your mirror just now. The same reason why mirror don't want to put at the floor. Same thing. I put at the top, at the sky, got nothing blocking it. Okay. Less obstacles. Less obstacles blocking the signal. Okay, K is the answer. I will not go through part C. You can go and try to do yourself because the formula is the same stuff. It's still going to be the D equals to VT over 2. Okay, but something I want to point out to you, this question a bit weird because of how they drew diagram 9.2. Okay, so you can try to answer this. Dana, move on. Okay, you can try to answer this, but you need to answer it thinking that S and R and the radar is all in the same straight line. Okay, so later at some point, you will need to find out the distance, and then you need to find out the distance. You need to use this formula. You can try and see later on. Okay, you have all the info you need, but you need to find all these distances to be able to answer the last part. Okay, and then again they ask, explain how the distance between airplane and radar can be determined. Answer the same way. Radar send out wave. Wave get reflected on the plane. Right, so the radar is going to hit the plane and then reflect. And then at last you receive back. Key point. And then how to determine distance? Speed times time, but divide by 2. 4 marks. The same one like just the previous question. Does anyone remember giga is times 10 to the power of 1? Yeah, very good.
All right.
10 to the power of 9. Hertz. So you will need this in order to find the wavelength in SI unit in meters also. Okay, the rest you try yourself. I want to do that one last one for chapter 5, page 32. That one is a difficult one. It's a killer question, this one. The wireless router one. Yeah, next page. Wireless router. Okay, you want it to transfer data faster, reached by wireless devices from a long distance. You want to state the location, the type of wave, the frequency of wave, the density of material, and the number of antennas. Okay. Trust me, if I ask from 5 students this question, a lot will have a hard time also. Okay, so I'm just trying to give you all more exposure. This is one that is trying to kill students. And it's section C, by the way. Section C cannot choose. Whatever they give, you must do. Let's start with the easiest one. Location first. Where to put the wireless router? Where to put the wireless router location? Yeah, or you can just say hi. I know normally you will say, oh, teacher, but my router's on the floor or my router's on the table, or those are not the most ideal places actually. You want to put as high as possible, less obstacles. Okay. Your grandmother gummed the router at the ceiling, is it? Small wireless router at a high location, a high position. Yeah. Anything that makes sense, lah. I think as long as you mention high, then okay. And it's the same reason. Third time we are seeing this already today. For mirror, for wave, for all this, so that we have less obstacle blocking the signal. The one I want to discuss is number 2. What wave would you want to pick? So your answer should come from the 2, either radio or micro. But for a router, you say radio, okay. Because communication again, then is this 2 again. Communication always this 2. Is it radio or micro? Yeah. Radio. Got people say micro also. The answer is radio. Please do in a table form, exam. So you just write left side, right side. Radio wave as the type of electromagnetic. I follow the question, wave use. Why not microwave? So guys, I picked radio wave because it is weaker than microwave. But do you think the reason I would say weaker doesn't sound very right? Now, what will you say? What's the advantage of using radio wave in this case? Spot on. That is spot on. Because it is easier to spread. Okay, guys, the more you want it to spread, the weaker the wave should be. When the wave is very weak, it will spread more. Yeah, that's right. Can I just remind you a quick one? That if you want more obvious diffraction, you should be thinking how to make it weak, not strong. If you want it to spread, it needs to be weak. If it's very strong, it won't spread one. If it's very strong, it will just go straight without spreading. What for I spread? I have a very, very strong wave. I won't care about spreading. I will just travel straight. Yeah. So a stronger wave might not always necessarily mean that it's the best. Okay. So we say it diffracts easily. Easy to diffract or diffracts easily. Okay, this one I put extra as it has longer wavelength. We all know that longer wavelength is a reason for more diffraction, more spreading. Those who don't know diffract means spread. Okay, or you can say wave can travel to a wider area. Wave signal can spread to wider area. Okay, so that's number 2. Now number 3, the frequency of the wave. Okay, between radio wave and microwave, we said radio is the weaker one, the lower frequency one. Radio versus micro. This guy has higher frequency, stronger. I use micro when I'm talking like communication satellite. Like if I need to go as far as the satellite, I need a very, very strong wave. Okay, but radio wave is normally for a shorter distance. Actually, guys, do you share your Wi-Fi with like your whole taman? Or do you use your Wi-Fi? You never do that. You never do that. Huh? You never share your Wi-Fi with the whole taman. So you don't need it to travel very far. Right? You don't even share it to the neighbor next door. Right? Or as in you have been using his. Then they put password. Okay, so for radio wave, I don't need it to spread go very far. Instead, I need it to spread around the house very well. So normally one house only have maybe one router, but this one router has to spread to the kitchen, to the hall, to every single room. You want it to spread sideways very well. That's why I want it to diffract very well. Now in question 3, do we want a high or a low frequency of wave? Radio is lower frequency, right? Compared to microwave. But what are you going to say about the frequency? Okay, a lot of people will say low because you think radio wave is low frequency. The answer is high. Again, if I don't go through this, how are you going to answer this in exam, right? Like these are things that you need to do questions only you will know. High frequency of wave. Now, high frequency because has higher energy, you can say. Okay, I know it's contradicting number 2 and number 3, but I'll explain in a bit. High energy, high penetrating power. So on. Okay. Please understand that what we're doing is this. Radio wave is not just one frequency is radio wave, you know. You need to know in that range of radio, it's a range. In the range of radio, I've selected radio, yes. But in that range of radio, there's a low frequency radio, and there's also a high frequency radio one. If you pick low frequency radio, it's too weak. Yeah, so I want the best of both worlds. I want my Wi-Fi to spread very well sideways. So I pick radio, not micro. And also, my Wi-Fi cannot just travel 2-3 meters, right? That's too weak. My Wi-Fi has to travel maybe like 10, 15, 20 meters so that it can go to the whole house. So it cannot be too weak as well. Understand that now we have selected radio. In that range of radio, this is the question. What they're asking is this. In the range of radio, I want high frequency radio. Okay, not between radio and microwave. Yeah, radio is lower and whatnot. Yeah, it's like this one. So that's why the answer for number 3 is this. Number 4 is on, okay, this one quite easy, density of material. High density or low density? What say you? The router box is usually made of what? Your router at home is made of? Plastic. And plastic, is it low or high density? Low density. Okay, a lot of the time, low density material, the reason you must write one word. That word alone normally is 1 mark already. What word is that? Do you know? You should speed. Router move. The router don't move, kan? Bro, we're talking about the outer layer on the plastic. The fact that it's made of plastic usually. Lighter, thank you. That one word is lighter. You write lighter. In a lot of the marking scheme, is already 1 mark. Right? But as a student, as a good student, will I leave a 1 mark reason? I definitely, if I have more to write, I will write more. Right? So yeah, you know it's lighter, but always state lighter lah. Or you want to say small mass pun boleh. Yeah, lighter, smaller mass also can. Same thing lah. Right? When you write like that, why you get marked is because you as a physics student, I'm able to see you know the relationship between density and also mass. Right? You know that when density is low, mass is also low. Okay, so lighter and maybe you say more portable or easier to install. I don't want a router made of gold, too heavy, very hard to install. And your grandma wouldn't be able to paste it on the ceiling, right? Too heavier. So more portable, easier to install, that kind of a thing. Okay, number 5, number of antennas. Your house got how many antenna on the router? Got 2, got 3. Okay. Okay, so what number should we write? My house has 3, so I go and write 3, and then you write that and GGD. Again, all I want is what? A general answer. You as the physics student here, you give me the best modification you have. Just say more.
More.
Yeah, thank you. More, many, multiple is fine. Yeah. Antennas. Don't give a number if you can. Reason? To strengthen the signal. Okay, you can use the word strengthen. To transmit more signals also can. To a wider area, let's say. Can I remind you that the word strengthen does not mean I increase the frequency and increase the energy? It's not this. It's not this concept. Strengthen just means that it is more signals. That's what strengthen means. Instead of having just a few waves, now I got triple the antenna, let's say, and I got triple the amount of waves. So the Wi-Fi bar will naturally be stronger. More waves is the number. Okay. What time was the last break? What time flies, huh? It's already 2 hours. Our second break now. Yay. Okay, now chapter 3. That is what you all want me to do. So last one, chapter 3. Can we look at page 9? Looking at the diagram alone, do you know what law this picture refers to? Okay, okay. That's not a law, that's right. That's the answer for part A. So centripetal force cause the satellite to orbit the Earth. But what law are you thinking about?
The first law and elliptical always done to this elliptical.
What law is this? Just looking at the picture, what are okay, you're getting close. You finally reached Kepler's name and Kepler's third law. Yeah, that's right. Kepler's third law. For those who don't remember, I always say this, right, in class. Okay, wait. What's this? What's this? Luckily you never say banana.
Eat the pineapple.
Do the pineapple. You cut it and then you eat it. Okay, thank you. Eat a pineapple. First law is talking about elliptical orbit. Kepler's second law is the law of areas. Third law is the law of periods, which says the square of the orbital period is always directly proportional to the cube of the orbital radius. And normally the picture to look at for this one is a lot of the time they are comparing 2 different orbits. Okay, 2 different orbits, 2 different distance. So that is the picture for Kepler's third law. The area picture, you can look at the next page. This one is the Kepler's second law. Okay, this one is Kepler's second law. This picture, this area shading and whatnot. The first law is just talking about the shape, how it is not a perfect circle. It is slightly oval shape, called an ellipse, elliptical orbit. Okay, can you try and see part B, the calculation? The orbital period of Q around Earth is 98.2 minutes. Calculate orbital period for P. Formula sheet will have a formula that you can use.
No, I'm not, bro, I'm checking this.
Yeah, it's not heat, it's gravitation. Yeah, this one, number 7. Okay, number 7. Thank you. You don't fight. Is that how you all always communicate? Yeah. Always like going to fight like that. You're then gangster lah.
Yes.
Okay, you can write like this, or the 1212, right? You can also write as PQ if you want. Okay, so like you can say this is P, and then this is for Q. Also can 12 PQ, same thing lah, right? The period, let's say for P, I want to find the radius for P. Okay, can I put 830 cube? Sorry. What's wrong with 830? Other than the unit? Thank you very much. The orbital radius, is it just 830? No. You also have to add this distance. Please be reminded, small letter r in any formula is always the distance from the center until the center. So it is missing this distance. You have to add yourself. Radius of Earth, did they give? Oh, they did. Radius of Earth. So actually, if you put km, it's fine. Just that you have to add the radius of Earth. And radius of Earth, because it's meters, I think I need to follow 830 change to meters. So your kilo, you can put 1,000, or you want to put times 10 power 3, same thing. Okay, but down there, I'm dealing with meter cube. Okay, for Q, they said the period is 98.2 minutes. Can I live in minutes or not? Can I live in minutes or not? Can, you can. Okay, so you know I've been stressing a lot about SI unit, and then this one suddenly don't need SI unit. Why is that? Well, because of how the formula looks like. For any formula that look left side, right side the same, left side and right side the same, t squared over r cubed, t squared over r cubed, look the same, huh? The units can always cancel. The units can always cancel, so you can leave it in meter. Guys, same for all the formula that look left side, right side the same. For example, all these ones. PV, V over T, V over T, P1 over T1, P2 over T2. There's one exception only. If it's temperature, it has to be Kelvin. Must be Kelvin, huh? But the rest can be any unit. Okay, I'm talking about all the formulas that look left side, right side the same, huh? Like this one and this one, the one that I boxed in red color. Left side, right side same, that can be any unit. Left side minute, right side also minute. Okay, like volume can be like liter, can be milliliter, can be cm cube, can be meter cube, can be so many different units, it's fine. But temperature must be the same, must always be Kelvin. That's the only exception. I'm not going to explain the reason why. I've done that in class last, so I don't want to waste time there. But temperature must be Kelvin. Okay, and then you can calculate. This is just calculator work. How good are you with your calculator?
Very good.
You're very bad with calculator.
Square times
Sorry, Shavin, I cannot really hear you. Okay, I'm gonna move this whole thing, come here as a times, and the answer you get for t squared is 10250.13, blah, 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 blah. I'm not really interested in this. I want to get the square root version. Answer is 101.243. This is in minutes. Yeah, you can just write the answer. Okay, the first mark lies when you get the first mark when you remember to plus the 830. Sorry. You remember to plus the radius of the Earth. That's the first mark. The entire substitution is another mark, and then the final answer is one. Okay, some people might get a slightly different answer, like 655, or this also can. As long as the front is 101. Depends on how much you round off. Here, some people round off a lot here. For me, I always say, go and square root your answer. Can. Square root, use answer button. Okay. Next one, part C. What happens to the orbital period if orbital radius increase? Increases, thank you. For this kind of what happened question, a lot of the time, 3 answers only, right? Increase, decrease, unchanged. Yeah? Why increase? Well, because I already said t squared and r cubed directly proportional. If your radius increase, your period also increases. Okay, the calculation part, if you are not getting the answer yet, you write down the answer first, later you try it out with your calculator. It's usually just calculator problem. The next question, can you, okay, so you quickly read through and then you will see this statement. Area covered is the same. This area and this area is the same. Okay, Kepler's second law states that if the area is the same, well, then the time taken to travel from A to B is equal to the time taken from C to D. Okay, so I'm going to pull it T1 and T2. So at the side here, I'm going to say T1 is equals to T2. But which side do you think is traveling faster? Earth is going around the sun, right? Earth is going around the sun. Which side is faster? AB, for what reason? Why you say AB faster? Because the distance is further. In the same amount of time, let's say the time 2 days, for example. Okay, in the same amount of time, you use your eyes to see AB travels so much more. AB travels so much more distance. It is faster here for sure, and slower here. Okay, so another way to see it is that if you are very close to the sun, right, closer, it means that you have a stronger gravitational force. And it also means that you will travel a bit faster at that distance. Okay, and if you are further, normally means you are slower. Because you have weaker gravitational force from the sun. Can you answer part A? I just want you to do part A, and then we'll move on. Position of the sun. If I write center, correct now? What's the term? What's the correct term? If not center, it is called what? Focal point. You do too much lens already. Focus is the correct answer. Center confirm wrong. Middle confirm wrong. Answer is focus. Okay. If you want to be very specific, you can say focus of the ellipse. That shape is called an ellipse. That oval shape is an ellipse shape. Okay. can you go to the page 12? Page 12. I think the concept that I want to cover, I already covered. Page 12. Can you do this whole question yourself? You try? Just 5 marks, I think. 1 or 4 marks only. The Negeri Sembilan one. 4 marks only. Page 12.
Yeah. This one, right? I'm just trying to figure it out. Yeah, we just don't.
I want to see your drawing. Okay, so you're drawing that, you're drawing that. You?
Allah, you Allah. I don't think I.
Okay, first one, everyone got correct. Then you, oh, because it moves in a circle, so the force is in a circle, is it? Like that?
Right.
So in diagram 1.2, you're gonna draw, how are you gonna draw like that? The answer is this.
What in the world? Let's say where I recommend
Actually, do you go for tuition for physics? No, just school. Okay, no wonder. Do you know that centripetal force is a type of gravitational force? Okay, now you know. Guys, centripetal force is a type of gravitational force, and for a thing moving in a circle, for example, Earth going around the sun, the object going in the circle is always attracted to the center of the circle. So centripetal force is always looking like that. It's a type of gravitational force. Guys, if you don't have this force, what happens? The object is going to travel this way.
That's why.
The object is going to travel this way, straight. What if I break the spring? Break the string. It's just gonna go straight. Okay. The same thing happens for what if there is no gravitational force acting on the Earth? Where will it go? The Earth will finally be set free and it will travel straight because the sun is no longer pulling it. Yeah, the sun is no longer pulling it to the middle. The force is pulling it to the middle to stop it from traveling straight. But the linear speed looks like that. Yeah, the linear speed looks like this. Okay. They ask you to, they write F, so you write there F, and then they ask to write V, then you write V nicely, F and V, which one is which? Okay, the V, let's say if you point down also okay. Okay, the V, let's say if you draw longer like this also okay. It must be a tangent to the circle. You all know how tangent looks like, huh? Tangent looks like this. It touched one point only. Okay. But what will happen to the throw distance if hammer is spin at higher speed? Of course, it will go further lah, increase. Easy. So. Further distance can, longer also can, more, greater. Oh, okay. Okay, it is following tangent. Okay, and then this is going to be the last question we'll do. I have 4 minutes left. The essay question in page 13. The Sarawak question. A network of communication satellite is needed to broadcast the live Olympic Games to the world. Some satellites are needed and placed at certain locations. Okay. Live broadcast. What satellite will you pick? I got 3 answers and they're all different so far. How about you boys? What's your answer? L. L? M? Okay, it is L. Let me give you. I got no time. I got no time. It is L. It is L. The answer is L. Okay. Now, why must it be geostationary satellite? So type of satellite, you say geostationary. Sorry, who said something? I heard something. It is correct. I heard something right.
Geographical location.
Okay, yes. I'm missing out the first word. So geostationary satellite. So satellite is always above the same geographical location. At all times. Please remember this, always above the same geographical location. Don't say always at the same location. If you say always at the same location means what? It means it is always stuck there in space and it doesn't move. Your satellite is moving damn fast. Your satellite is moving very, very fast. Always above the same geographical location means, for example, it is always above Kuala Lumpur. Earth is always moving, right? So Kuala Lumpur is not always at the same spot. Kuala Lumpur is constantly moving with the rotation of the Earth, right? And the satellite is also going to always follow. Okay, so for example, KL is here. The satellite is always above the same geographical location, meaning always above Kuala Lumpur. Okay, so every 24 hours, your KL city is going to go one round around the Earth. The satellite is also going to go one round together. Yeah, so geostationary will always answer like this. Don't write 120 degrees, that's a trap. Bigger angle of coverage. Yeah, wider can, larger can. To increase, or sorry, to cover a wider area, let's say. Of the Earth. Okay. Period of orbit is 24 hours. Okay, this one you can say it is same as the period of orbit of the Earth because you need to make sure that it always follows above Kuala Lumpur, for example. So it always needs to follow how the Earth rotates, and Earth will rotate 24 hours every round. Same. Okay, same what kind of period? Okay, same something period. You think, should I put rotation or orbital? Rotation, not orbital. Understand the meaning of this two words. Rotate means what? Means the Earth is rotating like this. Orbit means the Earth takes 365 days to orbit around the sun. That's orbit. The satellite doesn't take 365 days. Huh? The satellite takes 24 hours. So it follows the rotation. Same rotational period as the Earth. Or you can say the same one as just now. Always above the same geographical location. Okay, so can I just point down the above same geolocation, that one, huh? Also can. Okay, then number 4, I want less number of, you see, I don't write the number if I can, if I have a choice. Huh? Less number of satellite. Guys, more isn't always better in this case because satellites are very, very expensive. Very, very expensive to save cost. Okay, so satellite L is chosen. And then you must mention, because it has 1, 2, 3, 4, you copy back, put comma, 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 and paste here. That is the 10th mark. Okay, right. So in other words, if I got the Earth like this, one round, okay, I just need 3 satellites. 3 satellites. Okay, each will cover a wide enough angle, about 120 degree, and it is enough to cover the entire Earth already during the live stream of the Olympic Games, for example, right? So live stream communication satellite must be geostationary. Guys, if the question is mentioning anything about communication satellite, must be geostationary. Okay. All right, that is the end of today's session. Thanks for joining. I hope you found it productive, and you learned a lot. All the best. I wish you the best. Okay, just do your best. We'll stop.